Okay, welcome back. This video is going to be about the line of best fit, and it's going to be in three parts. First, I'm going to give you an overview, and then I'm going to have a video about errors or residuals and the least squares criterion, and that'll be in the second video. And the third video will be the calculation of B and A. So the first one, this is an overview. This should be fairly brief. As I mentioned previously, I have plotted the x and the y variables, and then you saw that I superimposed a line of best fit. And this line of best fit is really what we're interested in when it comes to regression. We want to be able to model the observations in such a way to derive a line that goes through the data points, these observed data points, as close to the observations as possible. So now think about what the ramifications are. That really what it does is it places a lot of burden on the observations that we make. So the observed data to us means something. And if you think back to the history of regression, the astronomers really believed in their observations. They believed that there was something that was true to each observation, but they also recognized that there was something that there was enough error or slop in each observation to not take each one seriously, and that should change the line. So if you take a look at this line of best fit, it's a straight line that goes through data points that don't really look like they're aligned together in a straight line. And I am going to show you some examples later on of data that clearly show a deviation from this straight line. But nevertheless, in regression, we assume that there's a rectilinear or straight line relationship for the most part, unless we model curvilinear relationships. But early on in this class, we're really going to focus on this straight line. So this straight line is the line of best fit, and it is the line of best fit because it minimizes error, and error becomes central to everything that we are going to think about, and we're going to discuss, and we're going to run diagnostics when we look at these errors, because it's the error or the error in our observations and potentially the error in our line of best fit that are most revealing of how well this line does fit our observations. So the line of best fit is, just as it seems from the title, it is a line that best fits the observation. Now, also remember that there are some restrictions to regression, and that regression makes certain assumptions about our data and how well behaved they are. So this line of best fit isn't necessarily the best line of all possible lines that could be drawn through these data points, because in this example, you can imagine that a line that would fit better would be something that kind of looks like, well, this looks like the Big Dipper or something like that. So there's a handle that goes up, and then it's a zigzag, so it might be some kind of weird Z or something like that. And that would be a line that would fit these observations much better, but it wouldn't be as principled as regression. So regression relies heavily on some principles to estimate what the line of best fit would be. And this line of best fit then becomes the expected values for each value of x. This would be the expected value of y. And we're going to go into errors in the next video. So this is the introduction of the line of best fit, and then we're going to move into errors and least squares criterion. So stay tuned.